Hello, it's me, Oscar from Marijuana Garden.
Alright, so there are 22 states of matter, including both common and, well, some exotic ones. Now let's talk about the common states of matter. First up, we have solids. These have a fixed shape and volume. Next, we have liquids. They have a fixed volume, but, they take the shape of the container they're in. So gases, well, they have no fixed shape or volume. They can expand to fill any container they're in. Pretty fascinating, isn't it? Plasma, now that's an interesting one. It's an ionized gas, and you can find it in stars and even in lightning. It's like the universe's way of showing off, don't you think? Condensed matter includes some really exotic states. These are the ones that break the usual rules and behave in surprising ways. Alright, so let's talk about the Bose-Einstein condensate, or BC for short. This is a fascinating state of matter that occurs when you get incredibly close to absolute zero. At this extreme temperature, atoms begin to act as a single quantum entity, almost like they're moving in perfect harmony. It's really mind-blowing when you think about it. Next up, we have the fermionic condensate. Now this state is somewhat similar to the Bose-Einstein condensate, but here's the twist. It involves fermions, which are particles like electrons. These fermions pair up in a way that mimics the behavior of BEC, but it's, a little more complex due to the unique properties of fermions. Pretty neat, right? And finally, let's dive into the superfluid state. This one is just incredible. A superfluid flows with absolutely zero viscosity. That means there's no resistance at all, which is, honestly, kind of hard to wrap your head around. Imagine a liquid that could just keep flowing forever without losing energy. It's truly one of the wonders of the physical world. So here's something really fascinating. The super solid. It's a solid, but it has superfluid properties. Imagine that. A solid that can flow like a liquid under certain conditions. Mind-boggling, right? Now let's dive into the quark-gluon plasma. It's a high-energy state where quarks and gluons, the fundamental building blocks of matter, are actually free from their usual bonds. This state is believed to have existed just moments after the Big Bang. Amazing, isn't it? And finally, there are other theoretical or lab-created states of matter. These are still being explored and studied, pushing the boundaries of what we know about the universe. Who knows what we might discover next? Degenerate matter, it's the kind of stuff you find in white dwarfs and neutron stars. It's fascinating, really, how matter can exist in such an extreme state. Strange matter. Now this one's hypothetical. It's thought to involve strange quarks, which honestly sounds like something out of science fiction, but it's a real concept in physics. Photonic matter, this is where light behaves as if it has mass, but only under very special conditions. It's like light taking on a whole new role, isn't that amazing? Time crystals, a fascinating form of matter that doesn't just change its structure in space but also in time. Yeah, you heard that right, in time. Rydberg polaron, imagine this, a single atom within a cloud of atoms behaving as if it's a single particle. It's like they all decide to move and act together, almost in harmony. Quantum spin liquid, a state of magnetic disorder that persists even at absolute zero. No matter how cold it gets, the magnetic moments never align. Pretty wild, isn't it? Excitonium, it's a fascinating state of matter made up of excitons, which are essentially electron-hole pairs. Pretty intriguing, isn't it? Polariton condensate, this one is a hybrid quantum state that blends light and matter. It's like the best of both worlds coming together. Disordered hyperuniformity, imagine a solid liquid-like hybrid where density fluctuations are suppressed. It's a bit of a mind-bender, don't you think? Alright, so here's something fascinating. The chain-melted state. This unique state of matter was discovered in potassium where, believe it or not, solid and liquid phases coexist together. Pretty amazing, right? It's one of those discoveries that really makes you marvel at the complexity of the physical world. A plasmoid, well, it's essentially a ball-like structure of plasma. Fascinating, isn't it? Color glass condensate refers to high-speed gluons found in atomic nuclei. It's pretty remarkable how these particles behave at such speeds. Preon stars, although hypothetical, are thought to be made of preons, which are theoretical particles even smaller than quarks. Just imagine the possibilities if they truly exist. So would you like a diagram or maybe some short notes for each? Let us know.